What order is this filter? What order is this filter?
Should be a first order filter.
Why?
Because the highest A sub 0 is 1. The delay.
Is that how we tell the order? By looking at the A coefficient?
Not the coefficient, but the delay.
Well, look again at this equation and tell me what the highest delay is.
I mean, the highest delay is 2, but do we look at the A or the B?
We look at the highest delay, whether it's in the A or in the B.
All right, the highest delay is 2.
All right, therefore we're gonna have 2 delays. So here's X coming in. There's X coming in. All right. Delay 1, I'm going to call that Z to negative 1 for reasons that'll become clear when we talk about Z transforms. And here's delay number 2. So right here we have X of n minus 1. Right here, X of n minus 1. And right here is X of n minus 2. And it says add 3 things together. Y of n. Add 3 things together. Add 0.5. There's coefficient 5. So right here is 0.5 X of n. Okay. This coefficient clearly is going to be 0.4. Because out here we're going to have 0.4 times X of n minus 1. And then we're going to have coefficient gain of negative 0.2. And out here it's going to be negative 2 X of n minus 2. And there's Y of n. Any questions about that?
This is a FIR filter, right?
Non-recursive are FIR, yes. Non-recursive filters are FIR. Any other questions about that? Let's do one more example.
I can see that page 1 second, please. I got to. I got it. Thank you.
Okay. What's the order of this filter?
I see it's
Yes,
Johnson.
Johnson. Yeah, that's correct, Mr. Johnson. Mr. Johnson. This is the third order filter. All right. Send me by email. Send me by email the difference equation diagram. Well, I expected something from all of you, but Ms. Buchap, you usually respond.
Hey, yes or no, Dr. Godwin?
All right. Yes, that's right, Ms. Buchap. And don't send it to anybody else, okay? Don't send it to anybody else. I want to see if people are understanding this.
Why you feel as if I send it to people, though?
Excuse me?
Why you feel as if I send it to people?
Well, I didn't say that you did. I said don't. I didn't say you do that out of habit. I just want to be sure you don't. I used to be a student.
I sent mine now.
Okay.
Would you say Dr. Carter used to be
I used to be a student too. I know that students share. I know that students just copy from each other. No, Miss Kerr, that's not right. There are two things wrong with that. There are two major things wrong with that. All right. Anybody else? Okay, pay attention, please. This is a third order delay. Therefore, we must have three delays. We must have three delays. Theta -1, theta -1, theta -1. This is x of n, the x minus 1. This is x minus 2. This is x n minus 3. We have a coefficient here from x of n. That's -0.2. Right here we have -0.2 x of n. And we need a sum of them. We need a sum of the ideas together. And this one down here is 0.4. Here is 0.4 x of n minus 3. Any questions about that?
So
Okay.
it will be at the bottom graph.
Excuse me?
The delay would be at the bottom, correct?
What does that mean, the delay be at the bottom graph? What does that mean? The third order delay is right here. That's where the third order delay is. This is the first order delay. This is the second order delay. This is three. Any other questions? Any other questions? Okay. Let's do. Let's go the other way. Tell me what this equation is.
You want to send it by chalk?
Send it by. Yes, send it by chat. If you have the textbooks, please don't send anything, because you only fool yourself.
Maybe they have the textbook, but I think you use it though.
Okay. Yes, Mr. Beauchamp. Yes, Mr. Johnson. They're both right. I know Mr. Johnson has the textbook. I wonder if he used it. Oh, wait. Ms. Beauchamp, Ms. Johnson, you're both wrong. You made an error. Look carefully. The output is the sum of three things.
Dakar, did you see my answer?
Who's talking?
Stewart.
Yes, I did. Yeah, that's right.
Got it. I sent something in, so.
What do you call coefficients are wrong? This occur.
All right.
And a delay is wrong.
You say a delay?
No, two delays are wrong. Look carefully at them. There's no x to n minus 1 on this diagram.
Oh, okay. Let me send it in again.
I mean, there is x to n minus 1, but it's not part of the output.
All right, let me send it again.
Pay attention, please. Clearly, the output is sum of three things. It's the sum of this, that's just x of n, and this is just negative 0.3 x of n minus 2, and the sum of this. So y of n equals x of n minus 0.3 x of n minus 2 plus 0.7 x of n minus 3. Any questions about that?
Any other tricky one in the book?
You call this tricky? Why you call this tricky?
I mean, it catch me off guard at first, but it's understandable now.
The problem is, it is a problem. The problem is students are not observant. That's the only problem. Students don't read carefully, especially this generation. All these questions are the same. You look at the output. What is the output? What is the output? It's a sum. It's a sum. Sum how many things? 1, 2, 3. It's three things. What is this thing? That's just x of n. What is this thing? That's just, you coming out here, well, that's x of minus 2. And when you go through the amplifier, it's negative 0.3 times x of n minus 2. What's going on here? X of n minus 3 is going here. The gain is 0.7. So what's on the output? 0.7 times x to the minus 3. This ain't hard at all. This just requires you to look at the circuit carefully. All right, that's all the work I'm going to do on non-recursive. Now we want to talk about recursive filters. That's IIR. And there you have it. There you have it. Straight from the textbook. This is called the direct form 1. The direct form 1 difference equation. The direct form 1 realization. As you can see before, this first half is nothing more than the FIR part of it. And the second part is we're delaying the y's now on the output. I'm multiplying by the coefficients. Again, what is this saying? This is saying right now the output is sum of 1, 2, 3, 4, 5, 6, 7. 7.
So to graduate a question like this coming on
The output is the sum of 7. 7 things. Everything I do in class. Why would you ask me such a question? You think I'm going to teach you something that I won't test you on, or try to test you on?
So it's just asking that.
I know you're just asking, but I don't understand why are you asking such a question. You are to learn everything I teach you because you are responsible for it. Right away, you're thinking I can't do this. That's what you're thinking right away. Yes, you can do this. You just have to learn it. Amplify it a little bit. If you understood what we just did with the FIR filter, that's just first part of it. The second part is saying y is what? The sum of 3 y values. Y delayed by 1, okay? Y delayed by 2, y delayed by 3. What order filter are they showing right now? If you ignore this dot M, what order filter are they showing?
You was breaking up. I think you asked it all. If you asked the order filter, that's the third order filter.
This is the third order filter, yes. And you can't see this clearly, but no, okay. Sorry, that's N, and that's M. Okay, so that's it keeps them going. All right, let's do something more dramatic. Oh, I need to go back a second. Back to recursive. What do you see here? Tell me what kind of filter you see here. In figure 416, what do you see? I got one answer in chat. This person said second order filter, but that's not true. Look carefully. We see a second order filter, there it is, followed by a second order filter. Second order FIR filter, second order FIR filter, followed by a second order FIR filter. So, what happens when you cascade filters? What happens to the order when you cascade filters?
Do you add them up? No.
Yes, you do.
So before then. Four order.
This is a fourth order filter. This is a fourth order filter. Second order FIR followed by a second order FIR filter is a fourth order FIR filter. And we could in fact find out what the overall difference equation is, but I'm going to leave that until after we've done Z transforms because it's easier to see it that way. Okay. But just like we cascade analog filters, we can cascade digital filters. Okay. Any questions about that? All right. Let me see what you do right in the equation. We'll write the equation for figure 422. Mr. Buchamp, you have the signs of the coefficients of the Y delays wrong. Just look at the diagram. Yes, Mr. Johnson, that's right.
I have a question, Dr. Godray.
Yes, go ahead.
You see how I write in the equation form, right? But you see,
Yes?
reason why I had the signs wrong, I thought like when I moving it across the equal sign, the sign of the change, but that don't happen with this one. I'm sure if you
Yeah,
understand.
man. No, I don't understand what you say because all I'm telling you to do is look at the diagram and sum what you see. When you look at that diagram and sum what you see, you don't see negative 0.1. One more person, please. Mrs. Stewart, you're getting in trouble because you're not writing. You're getting in trouble because you're not writing what you see. You are anticipating the answer and you're not writing what you see. All right, let's do it. Let's do it. I'm going to redraw it because I don't want to mess up my textbook. You see, you see 5 things being summed. That's what you see. 5 things are being summed. Just a second here. Okay. Those are the 5 things being summed. And what are those 5 things? Here's y of n. Here's y of n. So this would be y of n minus 1. This must be y of n minus 2. And this must be y of n minus 3. So right here must be 0.8. Y of n minus 3. Okay. Right here must be negative 0.3. Y of n minus 2. And right here must be 0.1. Y of n minus 1. Okay. And right here, here's x of n. Here's x of n minus 1. Here's negative 0.8. X of n minus 1. Is x of n minus 2. Is x of n minus 3. And right here is 0.2 x of n minus 3. Okay. So y of n is sum of 5. 1, 2, 3, 4, 5. Y of n equals negative 0.8 x of n minus 1 plus 0.2 x of n minus 3 plus 0.1 y of n minus 1. That's that one. Minus 0.3 y of n minus 2. Plus 0.8 y of n minus 3. Any questions about that?
Dr. Gard, I can see the page in the textbook one more time.
It's the same as you see on the diagram, on my diagram.
Dr. Ricardo, I have a question.
Yes?
On the page you just show us, why they had a negative sign to the coefficients, like of 8? But
All right, I'll answer that in a few minutes. I'll answer that in a few minutes.
All right, no problem.
Send me the A vector by chat. Send me the A vector for this. For this. For this filter, send me the vector. You're not finished, Mr. Duchamp. Johnson, you're wrong. Buchap, you're right. Waiting for one more person, please. One more person, please. The A vector. The midterm exam is a week from Wednesday.
Any guarantees?
What does that mean?
I mean, you normally just give a question, but you say guarantee coming.
I don't know if I normally do that. I sometimes do that.
So ain't nothing for this midterm.
I'm going to guarantee I'm going to test you on most of the topics we covered. All right, I see nobody else wants to try. Please pay attention. Write the A vector. We need all the Y's on the left-hand side. So from here, we go up here and we have Y of n minus 0.1, Y of n minus 1, plus 0.3, Y of n minus 2, minus 0.8, Y of n minus 3, equals negative 0.8, x of n minus 1, plus 0.2, x of n minus 3. Yeah, I'll give you a guarantee. I'll give you a guarantee that you must know how to find A vectors and B vectors. Because how else are you going to use the filter command? Steadily, this is A0. This is A0. This is A1. This is A2. three.
Hold on, you say
Mr.
filter command.
Mr. Chap, now to answer your question.
I didn't hear you.
Excuse me?
You say filter command? So that means we have to be writing codes then.
What was your,
No, I know my previous.
you have to know how to write code.
Yeah, that's answer my previous question now, but the negative signs in front of the coefficients. That's why I got it mixed up in the first place.
So what is this? What's that point one? It's negative A1. So the book didn't lie to you. What is this? That's negative A2. That's negative A2. The book didn't lie to you. What is this? That's negative A3. So the A vector then, the A vector is 1, negative 0.1, 0.3, negative 0.8. So, Mr. Buchap, did that answer your question?
Yes, sir, I completely understand now.
Okay. Send me the B vector, please. Send me the B vector. Mr. Johnson, that's not right. Apart from the fact that you left out the equal sign, yes, Mr. Buchap, that's right. Mr. Johnson, that's not right. Okay. Pay attention, please. I'm going to page 5 because this one's getting flooded. I'm just going to look at the right-hand side. Right-hand side of difference equation is negative 0.8 x of n minus 1 plus 0.2 x of n minus 3. And that's equal to 0 times x of n minus 0.8 x of n minus 1 plus 0 times x of n minus 2 plus 0.2 x of n minus 3. Okay, this is A0, that's A1, that's A2, and that's A3. So the B vector is 0, negative 0.8, 0, 0.2. Any questions about that? You must be able to find the A vector and the B vector. Draw this circuit for me, please. Send it by email. I mean, draw this equation. I think I said circuit. Draw this equation. Yes, this Beauchamp is right. Yes, Mr. Johnson, that's right. Anybody else? Okay. Pay attention, please. On the next slide. So we want to sum 1, 2, 3, 3 terms. So here's x of n through delay x minus 1. Through delay x of n minus 2 through a delay, then x n minus 3, and then we have through the coefficient negative 0.3, and the summa. There's a summa. This line here is negative 0.n minus 3. Here's our y of n line. Here's our output. And we need y to n minus 4, so we need 4 delays on the output. Right here is y of n minus 1. Right here is y of n minus 2. Y of n minus 3. And right here, y of n minus 4. And at y of n minus 2, we need the coefficient 0.5. And that goes up here. This 0.5, y of n minus 2. And then the last one we need, the coefficient is negative 0.3. And this signal here is negative 0.3 times 1 y of n minus 4. Any questions about that? What's the order of this filter? What's the order of this filter?
A support order filter.
Yes, it's the highest delay is 4th order. The 4th order IRR filter. Send me the vector, please. In chat, send me the vector.
Dr. Carter, did you ask a question?
Yes, send me the vector. You didn't hear me?
No, sometimes it be breaking up on my side. I don't know if it's my Wi-Fi or.
Johnson, you're wrong again. Mr. Beauchamp, you're right. Mr. Kerr, you're wrong. Okay, this must be, I don't know, at least the fifth time, not today, but all together, that I've showed you how to get the A vector and the B vector. Must be at least the fifth time. And there's still people who can't do it. And I don't know why they can't do it. They're just not following the rules. Please pay attention. I don't know how you all can get a homework done if you can't find the A vector and the B vector. You rewrite. The first step is rewrite the equation. All the y's are on the left-hand side. And all the x's are on the right-hand side. That's the first step. The second step is write in all the delays. So this is y of n, okay, plus 0 y of n minus 1, minus 0.5 y of n minus 2, plus 0 y of n minus 3, plus 0.3 y of n minus 4. So this is the right-hand side of the equation. And so A0 equals 1, A1 equals 0, A2 equals negative 0.5, A3 equals 0, A4 equals 0.3. Or the A vector is 1, 0, negative 0.5, 0, 0.3. Again, I ask, why is that difficult? It is not difficult. You just have to learn the rule. And you're not bothering learning the rule. Any questions about that? Send me the B vector, please.
Dr. Cartwright,
Yes.
when writing the outputs on the other side of the equation, is it formality for the Y delays to be before or after the X delays?
Well, it's sums that really doesn't matter.
All right.
Send me the B vectors, please.
I had to send you mine. You saw it?
Yeah, I saw that. Mr. Johnson. I saw Mr. Johnson. Somebody else, please. Send me the B vector. Oh, I said right hand side. Actually, this is left hand side of it. Left hand side. Yes, Mr. Johnson, that's right. Okay. Don't guess. I'm not getting anybody else's. Let's do B vector. So new page. So the right hand side. Difference equation. Negative 0.3. X of n minus 3, which is the same thing as 0 x of n plus 0 x of n minus 1 plus 0 x of n minus 2 minus 0.3 x of n minus 3. This is A0, A1, sorry, B0, B1, B2, B3. So the B vector is 0, 0, 0, negative 0.3. Again, why is that hard? Any questions? Okay, I hear no questions. I can't help you if you don't ask questions. So I think we'll end there for today. I remind you, the test is due after test. Everybody was sent the test. Ain't no doubt about that. If you don't have to test, I advise you to get it from your classmate. Have a good day.
Good Godric.
You do.
Yes.
You said Monday, right?
I said Monday for what?
For the test.
Yeah, man. Who am I talking to?
That's Kerr.
Why don't you read the test?
I because we get in two different things now.
What do you mean you're getting two different things?
Hold on. The test one, they're saying Wednesday, but you say Monday. I just want to make sure.
I did not say Monday. I did not say Monday. I don't know why you heard Monday. I did not say Monday.
My bad. Then I thought you heard you say Monday.
What's written in the instructions for the test is what's real.
All right.
Anybody else?